Okay, we are ready. Complex numbers continued. Last week we learned about imaginary numbers, and then in the lesson of imaginary numbers we talked about complex numbers. Do you guys remember that? All right, today we're going to continue with that. So part 1.
I have a question about it. So if we use like an imaginary number, can we use another letter besides J?
I.
Or, yeah, I.
No, you have to use I. Okay. Yeah, my eyes look like J's because I curl them, but the other way, not the J way. But you don't have to curl them, but you do have to use I, and not uppercase I, lowercase I. Okay. I don't know. Review. Number 1, simplify. Parentheses 5 minus 4i, close parentheses, take away 3 minus 10i. Number 2, let's write down before we do the work for number 1. Parentheses 2 minus 4i, the quantity of 2 minus 4i times the quantity of 3 minus 7i. All right, just looking at them, not working them out, how do these two look similar? They both have what? Parentheses, double bubbles. They both have i's. They're both complex numbers. All right, how are they different? Okay, this one's subtracting where this one is multiplying. Do we treat them differently?
Yes.
Yes. Which one do we do double distribution?
The second one.
This is the one where, what was the other word? It started with an F that for double distribution, F-O-I-L, FOIL, the FOIL method. All right, so double distribution or FOIL method. Is this double distribution? No. No, it is not. We're going to combine like terms after I distribute that negative. All right, so I'm going to let you guys do that now. Quick review. Distribute and combine like terms. Where this one, you're going to do double distribution or FOIL method. Go ahead and do that now on both of them, or work out both of them. David, put that away, please. Is that a calculator?
Yeah.
Is it a calculator on your phone? Then that you need to put away. You can borrow one of these. Yeah, let's put our phones away, please. Put our phones away. They shouldn't even be out on the desk because they distract us when they're out on the desk.
That's my mom.
No, put them away. Ladies, put them away. All right, first one, when we distribute, do I distribute the negative to both parentheses or just where the arrows here are going? To the right only? So the first one is 5 minus 4i, and then minus 3, minus or plus? Plus 10i, right? Okay, combining like terms, what comes first, the real number or the imaginary number? And does it matter? It does. Remember complex numbers we said have to be written like this, a plus bi. All right, so what's the real number once I combine them? 5 and negative 3 give me what? 2. Now when we combine like terms, we do not change the exponent. So like it will not become I squared, it'll stay I. What's negative 4i plus 10i?
6i.
Positive or negative?
Positive.
Positive 6i. Not I squared, positive 6i. Now, I told you guys last week, is it okay to have an answer with I in it? Yeah, it's a complex number. That's perfectly fine. I squared is not allowed. Does anybody remember from last week what I squared equaled? -1. All right, we'll need that for the next one. You didn't need it for this one, which is perfectly fine. Questions on this one? All right, next one. What's 2 times 3? 6. 2 times -7i. And then -4i times 3. -12i and -4i and times -7i. 28i what? Squared. Why is this one squared? Because we're no longer adding, we are multiplying. When you're multiplying like bases, you add the exponents. All right. These are typically our like terms, the ones in the middle, right? So 6 stays 6, and -14 and -12 add up to -26. I squared or just I? Just I. Now this is where there's an extra step from what we're used to. Plus 28i squared. Can I leave an I squared in my answer? No. What does plus 28i squared become? -28, and the I is gone. Why? Because I squared is what? -1. So this becomes -1, which changes the plus 28 to -28. And are there still like terms? 6 and -28 becomes -22 minus 26i. Final answer. Questions? Yes.
What if it was cubed, I cubed?
Good question. We will eventually learn, let me see if it is today. It is not today. We will eventually learn what is I cubed, what is I to the 4th, I to the 5th, even up to I to the 24th power. We will learn. That is a lot. And the reason it's, I don't want to say easy, but doable is because there's eventually a pattern. And we'll figure out that pattern. For now, all you need to know is I stays I, and I squared becomes -1. Got it? All right. Part 2. Part 2, divide by complex numbers. Number 1. 12 divided by 8i. All right, if I did no explaining whatsoever, what would you at least, very least on your own try to do in this problem? Reduce. Does 12 and the 8 reduce? What goes into 12 that also goes into 8? 4. Okay, so divide 12 by 4 in your head. Divide 8 by 4 in your head. What do we get? 3 over 2i. Do we all agree with that? Okay. Now here is where you have to think back to prior lessons. Or even just think back to Friday's lesson for now. What is I equal to? Not -1. What is I? What's the definition of I? It's the square root of -1. Can we have a square root in the denominator?
No.
Okay, even though it's in disguise, is I still a square root? Yes, so we cannot leave I in the denominator. And remember how we had that rationalizing step? It's going to be the same thing. Now, what's the problem? The 2 and the I, or just the I? Just the I. So because it's just the I, we do not need to multiply by 2i. We simply just multiply top and bottom by I, and that's it. Not 2i. If you do 2i, there's nothing wrong with that. You'll just have extra reducing at the end. If you want to bypass the extra reducing, then you simply multiply by just I. Okay, what's 3 times I? What's 2i times I? 2i squared. And we are not done because I still have the I in the denominator. But what's I squared? So it's 3i over -2. there's nothing wrong with leaving your answer that way. Myself, I don't like leaving negatives down there. I would bring it up to the middle or the top. But if you leave it down there, it's not wrong. And just know if you see it like on a multiple choice test as well, that's fine. Again, personally, I like mine either in the middle or at the top, but if you leave it there, that's fine. Okay, questions before we try number 2? Okay, 4 over 7i. Does it reduce?
No.
Okay, what do you multiply top and bottom by?
I.
I. I'm going to have you guys go ahead and do that quickly on your own. All right, I end up with 4i over 7i squared. Is that correct? What? No? Well,
Yes.
so far, there is an extra step. What does 4i over 7i squared become? 4i over negative 7. Now, I do want to talk about another way of writing it besides bringing the negative up. It's okay if you leave it like this, but technically the correct way would be like this. Negative 4/7 with I next to it. So you have your real piece and then your imaginary piece. Negative 4/7 I. Would I accept this one here?
Yes.
If you see this on the test, should you know it's the same thing?
Indeed.
Yes. Because you could put a 1 under the I, and when you multiply, you get negative 4 times I over 7 times 1, which is the same as this. Got it? Okay, number 3. 6 plus 2i over 7i. All right. How is this similar to numbers 1 and 2? It's a fraction. What's in the denominator of my fraction? An I. Okay, how is it different from numbers 1 and 2? Okay, the numerator has a 6 plus 2i, where all the others were just 12 and 4. Do you agree?
I agree.
Lucky for us, it's no different. What are we going to multiply top and bottom by? I. Again, if you choose 7i, that is correct. That is okay, but you're going to have more work to do at the end. So stick with just the I. The only difference here, well, let's talk about the similarities. What's the bottom going to be? Okay, you guys worked ahead. She said negative 7. Do you guys see how she got negative 7? Because 7i times I is 7i squared, which is equivalent to negative 7. Do we agree? Yes? All right, I'm looking for a math word. What am I going to have to do at the top?
Distribute.
Okay, I heard one person say it. Do we all agree with him? What is it?
Distribute.
Distribute. All right, so distribute your I.
Distribute. You're right. It's Leviosa.
All right, 6 times I is what? 6i. And plus 2i times I is 2i squared. Okay, we have more work to do. If I left it like this at the top, 6i plus 2i squared, why would I get it wrong?
Because it has an I squared.
Can we leave an I squared in the answer? No. I's we can have, but not I squareds. All right, so 6i plus 2 or minus 2? Okay. No, because I squared is negative 1, it's gone. So it's just minus 2. Be careful with that. When I squared, when you change it, the i's gone. Okay, I would still get this wrong. Can anybody tell me why? It has to do with this right here. What have we talked about with complex numbers?
Still square root.
What should come first? The real, yes,
Or the A.
the A being the negative 2 here. Do you guys agree with him? So what should I have? Negative 2 plus
6i
over negative 7. All right, and I want to just talk to you guys about another way you may see it, so when it happens, you do not freak out. Again, I will accept this from you, but technically, the right way to write it is like this. which I do not really have it in that form because of the fraction, I would have to rip my fraction apart like this. Negative 2 over negative 7 plus 6 over negative 7i. Do you have to do that? No, but if you see them in the test, should you know it's the same thing? And you would see it even simplified further. They'd write it like this: 2/7 minus 6/7 I. Because the negative over a negative becomes a positive, plus the negative is the same as minus, and then 6/7, and the I is pulled separately. Okay, so one more time, do you have to write it? Do you have to pull it apart? Technically, you're supposed to. Am I going to require you to do it? No, I'm okay with you leaving it this way.
Do it on the test.
Do you have to do the test? No, this, I'm okay with this. But if you're taking a standardized test, say one of my tests or like the SBAC test, and you see it written this way, should you see, oh, they pulled it apart the way Mrs. Torres said, and they reduced it. Positive 2/7 minus 6/7 I. Should you at least be able to recognize that? Yes. Yes. All right. Questions on part 2? All right. Number 4. Four minus I over 6i. I'm going to let you guys try that one on your own.
Whoa. And minus that.
Yes. What do we multiply top and bottom by? I. And don't forget to distribute. All right, do we have it? Yes.
I didn't get the answer, but I did get the equation. I don't know if that's right. I got 2i plus 2i. And I did the lower fraction bar or division bar, and then I did the 4i to the second part.
On this one here? Okay, it is going to come out to be a little different.
Okay.
And so let's take a look to see how. Peyton J, I'm going to call on you. No,
Pick up.
I don't get it.
just not even the distribution part?
You just distribute the I to all of them.
Yeah, so can you just tell me what that, at least what that part would be?
4I minus I squared.
Perfect. And what's 6i times I?
6I squared.
6i squared. Okay. Who can help us with the next step? Yes, Alik? Right here? So she's saying this I squared is negative 1. So it's 4i minus 1 or plus 1 if it's minus negative 1? Plus. Okay. Now, and can you tell me what 6i squared becomes? Negative 6.
Wait, I was confused on the top.
Okay, which piece? Where we got the plus 1?
Yeah.
All right. She said I squared is negative 1. Do we all agree with her? And then I pointed out it's minus negative 1, and minus negative 1 becomes positive 1. I'm still not quite done with this because I need this in the right order. So which way should I write it?
1
Plus 4i over negative 6. Now, if you were to split it and recognize it, the first part would split to what? Negative
1 over 6
6, and then the second piece plus or minus?
minus
minus, and 4 over 6 reduces to?
But the first one could be the answer.
Yes. Yes, this is the one I'm going to take from you guys, is just in case you ever see it, should you know it's the same thing. Indeed. All right. Number 5. 3 minus 6i, not an I, 3 minus 6i over 12i. 3 minus 6i over 12i. And I'm going to have you guys work that one out. I put parentheses in the denominator out of habit. It's not necessary.
Wait, could you reduce those now?
Good question. Could we reduce these? Anybody else think that when they were looking at it?
Yeah.
Okay. How many of you didn't reduce and already distributed? Okay, I'm going to reduce at the end then, and it is okay if we reduce at the end. All right, Jeremiah, can you tell me what you got when you distributed this?
3i
Keep going.
and negative 6i squared.
Keep going at the in the denominator.
12i squared.
Perfect. Does everybody agree with him? Yes. Christina, what do you get right here?
Negative, well, the I squared is -1, so then it'd be just 6.
Plus 6? All right, do you guys agree? Minus 6, and then that's a -1 becomes plus 6. And then 12i squared is? All right, what do I do with this piece right here? Switch it where it's in the front, yes or no? So 6 plus 3i over -12. How many of you got at least this far and then realized maybe I can reduce? Yes? Okay, now you can only reduce if you can find a number that goes into all 3 terms. For example, over here, kids will say, oh, I can reduce by 2. But does it all divide by 2? No. So here, what goes into 6, 3, and 12? 3. So you're going to take this and divide every single piece by 3. Okay, what is 6 divided by 3? Plus, what's 3i divided by 3? 1i. Over, what's -12 divided by 3? -4. Does anybody want me to show you what it looks like split up, or are we good with this answer? We're good with this answer?
Wait, could we reduce it
Even further? Good question.
to just I over -4?
Because of this here?
Over -3.
I can't reduce this any further because I'd have to find a number that goes into all 3, and there is a 1 here. Does 2 go into 2, 1, and 4? No, the 1 here is not allowing me to. Do you see that? All right, questions?
Is that all we use?
That is